We've all experienced that frustrating moment when a phone simply can't handle the heat. You're at the beach, sitting by the pool, or using your phone for GPS on a scorching summer afternoon. Then suddenly, the display dims. Video recording starts to stutter, performance drops, or you get that dreaded message. Phone needs to cool down before you can use it. And in 2026, thermal management has become much more important than it used to be. It's no longer just about having the fastest processor, the biggest camera, or the fastest charging speed. If a phone can't control its temperature, all that performance means very little. So today we're looking at the 8 phones that stand out for their cooling systems and their ability to handle heat. And before we get into the ranking, there's something important to understand. Modern heat resistance isn't based on one component. It's a combination of hardware and software working together. We're seeing advanced vapor chambers that move heat away from the processor and battery, graphene layers that spread hot spots across a larger surface, more efficient processor designs that generate less heat, bypass charging that can reduce battery-related heat during heavy use, and even phase change materials designed to absorb thermal energy before performance starts to drop. So with that in mind, let's start with number 8. We have the Xiaomi 17 Ultra. Xiaomi uses its Ice Loop cooling system, which is inspired by cooling systems used in satellites. The idea is fairly simple. Liquid coolant is moved toward the heat source, where it vaporizes, travels toward a cooler area, and then condenses again. But the more interesting part is the 3D dual-channel cooling system. The phone uses a large 5,500 square millimeter vapor chamber with a bionic microstructure designed to improve thermal conductivity by up to 50% compared with older designs. And this matters because the Xiaomi 17 Ultra isn't only dealing with gaming workloads. If you're spending hours taking photos or recording video at a summer festival, the phone still needs to keep the processor and image processing under control. That's where the cooling system becomes useful in real-world situations. It's not simply about lowering a temperature number, it's about keeping the phone responsive when the workload stays high. So the Xiaomi 17 Ultra starts our list with a serious cooling setup, especially for people who combine heavy camera use with demanding performance. At number 7, we have the Sony Xperia 1 Mark 8. Sony is targeting professional creators here, and one of the biggest problems for mobile videographers is obvious: heat during long 4K recording sessions. The Xperia 1 tackles that with heat suppression power control. Instead of sending power through the battery while the phone is plugged in, the system can power the phone directly from the charger. That helps eliminate one of the major sources of additional heat during long recording sessions, gaming, or streaming. Inside, Sony combines a large vapor chamber with graphite heat diffusion sheets to move heat away from the Snapdragon 8 Elite Gen 5 processor. The vapor chamber pulls heat away from the chipset, while the graphite sheets help spread that thermal energy across the chassis instead of allowing it to remain concentrated around one area. But there is an important reality check. During prolonged 1-hour CPU stress testing, the processor can still throttle as power demand remains high, and the phone can become noticeably warm, especially around the upper rear camera area during intensive 4K recording or maximum settings gaming. The positive side is that demanding games can generally maintain frame rates above 50 frames per second under these conditions. So the Xperia Mark 8 isn't completely immune to heat. Instead, its strength is controlling the heat intelligently, particularly when you're recording or using the phone while connected to power. At number 6, things get much more serious. The Ulefone Armor 29 uses graphene cooling technology with a huge surface area of more than 15,000 square millimeters. The purpose is to pull heat away from the Dimensity 9300 Plus processor and reduce CPU temperatures by up to 4.6 degrees, helping prevent performance from slowing down during heavy workloads. But this phone has another advantage. The Armor 29 Ultra is designed to operate in temperatures up to 55 degrees indefinitely. Its thick reinforced casing also provides insulation against external heat, while the phone uses a specialized high-temperature battery chemistry designed to reduce the swelling and degradation that can happen to standard lithium-ion batteries during extreme heat. And unlike many rugged phones, this one isn't relying on a weak processor. You get the Dimensity 9300 Plus chipset, coupled with 16 gigabytes of RAM and up to 1 terabyte of internal storage. That combination gives the Armor 29 Ultra considerably more processing power than you would normally expect from a rugged smartphone. And with that much performance inside a rugged body, cooling becomes essential. That's why the integrated graphene cooling system is such an important part of the phone. It's designed to keep the CPU and GPU under control even when the workload continues for a long period. So if your priority is surviving harsh environments, rather than simply having a premium-looking flagship, the Armor 29 Ultra becomes a very interesting option. At number 5, we have the OnePlus 15. OnePlus has always focused heavily on speed, but in 2026, the company is putting just as much attention into controlling the heat that comes with that speed. The centerpiece is the cryovelocity cooling system. It uses a dual-cycle liquid cooling design, with one cycle dedicated to the processor and another handling the 120-watt super-speed charging coils. That second part is especially important because fast charging can generate a lot of heat. The cooling system also uses a 5,700 square millimeter steel vapor chamber to rapidly move processor heat away. Then there's aerospace-grade aerogel insulation, designed to reduce thermal transfer toward the display, along with a white graphite layer that helps remove residual heat around the chipset and camera area. And this is where the OnePlus 15 becomes particularly interesting for summer use. The phone is designed to maintain its fast charging behavior even when ambient temperatures rise, allowing it to go from 0 to 100% in under 30 minutes. So the OnePlus 15 isn't just trying to cool the processor. It's managing multiple heat sources at the same time. That makes it a strong choice if you want high performance, but also care about fast charging without excessive thermal buildup. At number 4, we have the Google Pixel 10 Pro. For years, heat management has been one of the areas where Pixel phones could struggle, but the Pixel 10 Pro takes a different approach. The phone uses the Tensor G5 as being manufactured on an ultra-efficient 2-nanometer process. Instead of focusing purely on raw clock speeds, the design prioritizes efficiency, and that becomes especially useful during workloads like AI processing and GPS navigation, where the phone can remain under sustained load for long periods. Google also introduces Thermal AI too. The idea is that the system can predict temperature spikes before they happen and adjust background processes accordingly. That means thermal management isn't happening only after the phone gets hot. The software is trying to prevent unnecessary heat buildup in the first place. The Pixel 10 Pro also gets a vapor chamber inside the Pro chassis, which helps move heat away from the Tensor G5 during demanding workloads. And this is an important difference from the standard Pixel 10, which uses a more basic graphite cooling setup instead. So the Pro model's clearly the one to choose if thermal management is a priority. However, there is still a reality check here. User feedback is mixed, with some reports of heat soaking and high skin temperatures during prolonged outdoor GPS use. So while the hardware has improved significantly, software tuning can still make a difference. That puts the Pixel 10 Pro at number 4. Much better thermal engineering, but not completely free from heat under extreme conditions. Now we get into the phones designed specifically for people who push their devices hard. At number 3, we have the Asus ROG Phone 9 Pro. The ROG Phone 9 Pro uses the GameCool 9 thermal system, including the AeroActive portal. And yes, there's literally an opening in the chassis that works with the external AeroActive cooler, but the internal design is just as interesting. The phone uses a 360-degree cooling system Gen 3 layout, positioning the Snapdragon 8 Elite processor in the center of the phone between split batteries. That helps move heat away from the areas where your hands are normally gripping the device. Asus also increased the graphite sheet by 57% and added a rapid cooling conductor to improve heat distribution. Even without the external cooler, the phone uses boron nitride thermal material, designed to conduct heat more effectively than standard compounds. And if you're playing demanding games like Genshin Impact or Call of Duty Mobile for extended periods, this kind of thermal design becomes much more important. Because gaming isn't just about peak performance, it's about maintaining that performance after the phone has already been running for a long time. And if you want to go even further, the AeroActive cooler provides active cooling, while the ROG Chill case is designed to reduce surface temperatures by up to 17%. So for gamers and power users, The ROG Phone 9 Pro is one of the most complete thermal packages on this list. At number 2, we have the iPhone 17 Pro Max. Apple has moved away from relying purely on traditional internal heat sinks and introduced a graphene-infused thermal chassis. The graphene layer is bonded to the internal frame and is designed to pull heat away from the A19 Pro chip and spread it more evenly across the back of the phone. But the major addition is the Apple-designed laser-welded vapor chamber. It works together with the aluminum unibody structure to move heat away from the processor and distribute it through the chassis more effectively. This can reduce temperatures by up to 6 to 10 degrees during heavy workloads such as gaming and 4K recording. And there's another part of the system that directly affects the summer experience: the display. Historically, extreme heat could force iPhones to dramatically reduce display brightness. The iPhone 17 Pro Max introduces a lower voltage display panel designed to generate 25% less heat, helping maintain better visibility in extremely hot outdoor conditions. The vapor chamber itself uses a phase change liquid. When the processor area becomes hot, the liquid evaporates, moves toward cooler sections, and then condenses again. Internal wicking structures then return the liquid toward the heat source. Combined with the aluminum frame, the system is designed to spread heat more efficiently than previous titanium-based designs. And the real benefit is sustained workloads. Long video recording, on-device AI tasks, and other demanding processes can run without the same sudden surface temperature spikes. That makes the iPhone 17 Pro Max a very strong all-around option if you want flagship performance with much more serious attention paid to thermal management. But there's still one phone left, and according to this ranking, it takes the crown. At number 1, we have the Samsung Galaxy S26 Ultra. Samsung has reclaimed the top position in thermal management with what the source calls the Titanium Vapor Shield 3. The headline features a massive 12,000 square millimeter vapor chamber, described as the largest ever used in a mainstream flagship. It can dissipate heat 40% more effectively than its predecessor. And this isn't just about the vapor chamber. Under the hood, the Snapdragon 8 Elite Gen 5 is built on a 3-nanometer process, helping reduce heat generation compared with previous generations. Samsung also uses an advanced thermal interface material around the processor to improve heat transfer. Then there's the multi-layer thermal stack, combining the vapor chamber, graphite sheet, thermal pads, and thermal paste layers into one system designed to maximize heat dissipation. And this is where the Galaxy S26 Ultra earns the number 1 position. The phone is designed to maintain high performance even during extremely demanding workloads. The source specifically highlights 8K video recording at 120 frames per second under direct sunlight, where the S26 Ultra is described as maintaining peak performance without aggressive thermal throttling. So if your priority is reliability under extreme heat, sustained performance, and a cooling system designed around a very demanding flagship processor, the Galaxy S26 Ultra is the strongest overall choice in this ranking. In conclusion, even if you don't upgrade to a 2026 thermal powerhouse, you can protect your existing phone during summer heat waves with these practical tips. Ditch the thick rubber case. Dual layer and heavy rubber cases act like insulated winter coats for your phone. In high summer, switch to a thin, breathable mesh case or a heat-dissipating polycarbonate shell. Avoid charging in direct sun. Charging generates heat internally. Sunlight generates heat externally. Combining the two is the fastest way to permanently degrade your battery's health. Use dashboard mounts with vent clips. If you use your phone for GPS navigation, place it on a clip mounted directly in front of an air conditioning vent inside your vehicle, rather than sticking it to the windshield glass. Enable dark mode and lower brightness. Driving a display at max nits accounts for up to 40% of thermal generation. Reducing manual brightness slightly extends outdoor usability significantly. So, if you are buying a phone specifically for hot weather, heavy gaming, long recording sessions, or demanding everyday use, which one would you choose? Let me know in the comments below. And if you enjoyed this comparison, consider subscribing for more honest smartphone tests and comparisons. Happy watching and see you in the next one.